There are many ways to view multiband image data. Here I'm going to explore some of the display options for a multiband raster image in QGIS Desktop. So I've got QGIS Desktop open and I've loaded the aerial photograph, which is a portion of the Davis-Perdue Agriculture Center in Randolph County, Indiana. On the way in, I went in and set the coordinate reference system to EPSG 32616, which is UTM Zone 16 with the WGS84 datum. I'll begin by opening the Layer Properties window. So I'll double-click on the layer to open that window, and we'll start on the General tab. The Layer Info section shows me the layer name, where the data is stored on my computer, and the number of columns and rows in the image. Below that, we've got the coordinate reference system, and then scale-dependent visibility. This allows you to control at what scales the layer is visible. I'm not going to set this parameter here, but if I wanted the image to be visible only at a certain scale range, I could check the box and enter a scale maximum and minimum. Now I'll switch to the Style tab. This image has 3 bands, and each band represents a segment of the electromagnetic spectrum. In this case, band 1 represents the red portion, band 2 the green portion, and band 3 the near-infrared portion. Therefore, in this image, we're able to see characteristics of the landscape that we can't see with the naked eye, since our eyes can only detect visible light. When an image has multiple color bands, QGIS defaults to a multi-band color renderer of that image. Colors on your computer monitor are created by combining the 3 color channels, red, blue, and green, and by selecting 3 bands from a multi-band image and illuminating them with either red, green, or blue light, we create a color image. The multi-band color renderer defaults to displaying band 1 through the red channel, band 2 through the green channel, and band 3 through the blue channel. However, I can change which bands are displayed through which channels. These are called band combinations. So now I'll change the band combination. I'll change the red band to band 3 and the blue band to band 1. And I'll click Apply. Move this out of the way so we can see the image a little better. This band combination creates what is called a false color composite. Here, vegetation reflects a lot of near-infrared energy, and you're looking at the near-infrared through the red channel. So vegetation shows up as red tones. The brighter the red, the more vigorous and healthy the vegetation. The Style tab also allows you to adjust the contrast enhancement. This setting gives you the option to modify the appearance of the image when used in conjunction with the load min max value settings. By default, the renderer is set to use cumulative count cut values from 2% to 98%. This setting eliminates the bottom and top 2% of the values. Many images have some outlying very low or very high data values, and these outlying data values can be eliminated using this cumulative cut count setting. The contrast enhancement is set by default to no enhancement. Right now I'll click the load button to see the values being used for each band with these settings. And you'll see the values populate min-max in each band. Now I'll change the contrast enhancement to stretch min-max, and I'll click Apply. This setting scales the colors between the minimum and maximum values. The image gets a little brighter because the colors are now being stretched across the range of values. I'm both applying a stretch and eliminating the bottom and top 2% of the values with the default cumulative count cut setting. The accuracy setting lets you either estimate the range of values from a sample or get the actual values. Obtaining the actual values can take a little longer since QGIS has to look at all the values in the image instead of just a sample. So I'll change the accuracy to actual, and I'll click the load button, and you'll see the values up here change. Now I'll change the load min-max values setting to mean plus or minus standard deviation. And I'll click load, and you'll see the values again change, because instead of using cumulative count cut, we're using mean plus or minus standard deviation. And I'll click apply to see the change on the map. The colors in the image become more saturated now. These are the values within 1 standard deviation of the mean value. So this is useful when you have 1 or 2 cells with abnormally high values in a raster grid that are having a negative impact on the rendering of the raster. I can also look at one individual band by changing the render type to single band gray. I'll click the drop down for render type and choose single band gray, and then I can choose which band I want to be looking at. We'll start with band 1 and click apply. This allows me to see the data in each band. You can see how the data is different in each band. The image changes quite a bit. So let's change it back to a false color composite. Our band combination will be 3, 2, 1. We'll again set our contrast enhancement to stretch min max. I'll set this to actual, click load, and apply. Next, let's look at the transparency tab. With this global transparency setting, you can control how transparent the entire image is. You can also define image values that you want to be transparent. Notice that in the southwest corner, there's a black rectangle with no image data. I'll click this Add Values from Display button, and then click on that black rectangle. You can see it has a red, blue, and green value of 0, 0, 0, and I'll make that 100% transparent and click Apply. The black rectangle with no data pixels now disappears. Raster datasets can get very large, and pyramids help render images more quickly. So we'll switch to the Pyramids tab. Without pyramids, QGIS will try to render each pixel in an image, even though your monitor may not have enough resolution to display each pixel. So pyramids are lower resolution versions of the image that will increase performance. This particular image is small, so I won't build any now. But if I wanted to, I could just select these resolutions and tell it to build pyramids. Now we'll switch to the Histogram tab. Here I can view the distribution of data values in the raster image. If it's a multi-band image, I can view data for each band. So you can switch the bands out down here, band 1, band 2, band 3. The histogram is generated automatically when you open this tab. You can save the histogram as an image with the Save Plot button. So now you've become familiar with all the things you can work with in the layer properties of a multi-band image. In the next task, you'll learn how to perform a supervised classification.